Hey there folks, thanks for tuning in to the Speaker Builder channel. Today I'm going to be talking all about how to build five-sided boxes. I had a viewer request that for me, and so I thought it warranted a whole separate video. I do talk about this at some length in the video on truck speakers. You can look at those, but part 2 and part 3 in particular. But I thought it warranted a whole separate video, and I'm going to try to keep this brief. But so first of all, what do we mean by five-sided boxes? We mean here, if I turn this up, you see the pentagon shape. And the issue is there are no parallel walls. And so you're avoiding the parallel walls. That's the issue with a traditional rectangular shaped box. You have 3 sets of parallel walls in such a box. And while these are traditional, there are a few exceptions out there. There's the, I think they're B&Ws, and they have a curved back to them. So that the back panel has a curve to it like this, and this side is curved like that. So these are not parallel, and there's no parallel front to back. Really nice design, but I can't build that, of course. I have flat material to work with when I build boxes, as most of us do, so we don't have a factory. So we're going to build a panel, we're going to build a box with flat panels, and so the five-sided shape is a way to get out of the parallel walls, with the exception of the top and bottom. And there's actually a workaround I'm going to incorporate in this new project. Now the issue has to do with parallel walls producing standing waves, and I'm not the engineer, so someone else can talk about that, but I know that it's effective. If you go look at the video called Speaker Box Shape, in that case we're talking about bass speakers, and I demonstrated by building the worst case scenario, a cube-shaped box, in which the 3 sets of parallel walls are all the exact same size and distance from one another. And that produced the worst case, it was a boominess that I heard in those boxes. So that's the thing we're trying to avoid. Even in low frequencies, you'll produce standing waves. Certainly with a mid-range driver going up to 2,000–3,000 cycles, you're going to produce some standing waves. Those wavelengths are going to be relevant given the distances involved in the internal dimensions of the box. So let me go right into now, rather than spend any more time on that, let me go right into calculating the box dimensions next. So the first consideration we need to think about when building a five-sided box is the basic shape of the box. For a given internal volume, it can either be narrow and tall, or it can be wide and short. And my preference is going to be the tall and narrow design, partly because it just looks better, I think. But there are several other considerations here to think about. One is the size of the top and bottom panel, being those are going to be parallel. We would like to make those as small as possible. Now I actually have a workaround in this case in which I'm going to attach. You can attach just about any kind of material you want to either the top or bottom panel and eliminate your parallel wall issue between top and bottom. And that's what I'm going to do here. I haven't actually decided which of the various methods I've thought about. It could be anything. Any kind of material, wood pieces glued to the bottom of the box or the top will eliminate your parallel wall problems there. But anyway, we want to shrink those down. That's another consideration besides the look. The overall look is for me preferable. Another consideration is that you have in this case a satellite speaker in which you're going to have drivers mounted in the front, and you want very little panel present. In this case the box internal volume had to be very small, so I necessarily had to make it very short. And so you're going to have the mid-range here, and then there'll be a tweeter up here, of course. And so you want very little panel presenting itself to the listening area. The reason why tower speakers are so narrow is because they don't present any panel to the front listening area. So that's another consideration. I like it narrow for that reason. The other consideration is the fact that with a wide panel, there would be more distance between the glue joints and greater chance for panel vibration being set up. That's not so much a concern here with such a small box as this, where it's 3/4 thick. But in the large boxes I'm building to match these, that box is a little more susceptible to vibration, panel vibration, because of the size. So the narrower we make it, the less material there is between the glue joints, the stronger it will be and the less susceptible it is to panel vibration. So those are the main considerations for producing this kind of a shape. The other consideration in determining the actual width of the front panel, and in fact there's consideration for the width of the inner panel as well. You're going to have to cut this out and put a driver in there, and especially with the mid-range driver, that cutout is only a little bit less in diameter than the actual diameter of the driver. And you really don't want to have that round cutout cutting into this material here. You want that staying within here. So your inside dimension width should be no smaller than the inside width of your cutout. And so you can calculate that. You take this dimension here, whatever this edge dimension is here, times 2, and subtract that from your total width, and you get your cutout size. Some drivers, the material that you get, the specs you get with the driver will actually tell you what the cutout size is. But that cutout should not be greater than the inside dimension here. I hope that makes sense to folks, because you don't want to be cutting into this side panel. So that was a consideration here. I had to kind of keep the outside panel was, minimum outside panel was dictated in part by the minimum inside width. And by the way, I have this listed, but there's about a 1 1/8, technically 1 1/8 inch difference between inside and outside. As I measure this box, it's about 1 inch. So, but technically, if you do the math, it's about 1 1/8 inch. So let's talk a little bit about how to calculate the internal volume of the box. Starting with the width, this is the inside width. Remember, I made that distinction just a moment ago between the outside and the inside width. So this is the inside width, naturally, for internal volume. So you take that number, whatever that is in inches, and you divide by 2, and then you square that, multiplied by itself. So suppose this was a, let's make up a number, it's an 8-inch wide box. Internal dimensions, 8 inches wide inside. Divide that by 2 is 4, square that, you get 16. I hope that makes sense. And so whatever that number is, do it with a calculator, get it exact, because this is like, I've got 4 and a 3/8 inch or something like that. So I have to actually take 1, divide by 8, then multiply by 3 for 3/8 or something like that to get it actually to a decimal point. So then you multiply that number, whatever that width divided in half, and then multiplied by itself. You multiply that number again by 6.88, and you'll get the area of the box. That's in square inches, the area inside here. So it's a very simple formula to calculate that, and it should be clear then that once you get that area, now you multiply that area figure times the height of the box. In this case, I think I have, what did I do? 10.5, I think, is 11.5 inches is what this is, because this is going to be total 13. So 3/4 top, 3/4 bottom is another 1.5 inches. So the total was 13, the target. So this is going to be 11.5. So whatever my area is times 11.5, that's going to give me my volume in cubic inches. Then I can divide by 1728, and I can get my cubic feet calculation. I happen to be getting the internal volume target in cubic feet. It's 0.15 is the target for this driver. And so my box actually ends up being about a 1/4 of a cubic foot, 0.25. So I'm going to have to shrink in the internal volume down quite a bit by using materials, gluing materials inside that top and bottom panel. That's how I'm going to deal with that. It deals with the parallel top and bottom panels, as well as reducing this internal volume. This is a sealed alignment, and so the internal volume is not so critical in a sealed alignment box. You can raise that quite a bit, up to at least 0.2 from 0.15. So, and then of course I already mentioned this, the outside width is about a 1 1/8 inch less than the inside, or the inside width added to 1 1/8 inches equals the outside width. And as I say, measuring wise, it's about an inch or something as I actually measure it. So we've got the basic dimensions now down about calculating the shape of the box and the internal volume. Now I'm going to talk a little bit about how to actually build them. And I have two of these naturally, and I've taken one out, taken the panels, brought the panels up to show you how I might cut this. So this material then, back this out a little bit, I took this out of one panel, and it's a nice idea to actually take one piece of panel of wood and you can even mark them. I don't know if you can see that in the video. I marked little T's. They're upside down in the video here, but little T's because I want those all to be on the top, and then these are at a B for the bottom. So you take a single piece of material here and you run it through the saw on a fence, and now you have exact parallel top and bottom. And so when you put that together, you get an even top and bottom, and it comes out and it sits flat. So that's actually important that I had to learn. Then you take that piece and then run it on the fence this way with the fence here now. And you start with a square corner, by the way. So if I take a piece of factory material from the 4x8 sheet that I get, it has factory square corners that are exactly 90. So I'll cut a piece. I might use a skill saw and cut this piece rough here and here, but I know I have a square corner here. Then I'll take this with this on the fence and cut my 11.5 here on the fence so that I have a nice square piece that's 11.5 wide by, doesn't matter what the length is. Then I'll take this piece and I run it to the saw this way with the fence over here, now set at whatever it is, 5 3/4. I actually set it at 6 because I'm going to make these angle cuts later. So I cut it at 6, make it a little wide so I have plenty of material to work with. But now you run that through once, twice, 3, 4 times, 5 times, you'll get your 5 pieces. The idea is you get, these 5 pieces are all exactly the same height, and they're now, of course, all the same width. Now I go and set my blade at 36 degrees. Now I actually bought a tool. It's a bevel tool that you can adjust, and it has a digital meter on it. And you can take that meter and you can actually put it on here, set the bevel down and look at what the gauge reads and make sure you're getting 36. Or 54 is the other. If this is 0, then that might be 54 as opposed to that's 90, right? That'd be 54. That's the same as 36. So 36 or 54, both of those added up are 90 degrees, right? So whichever it comes out to be, you want to make sure that's exact. So I do a test cut. You could test cut a rough piece of material and see that you're actually getting what actually happened in these boxes. It was ½ degree off. So I added I made the second cut a ½ degree the other way, added a ½ degree, whereas I lost a ½ degree on the other side, so that I end up with a box where all the corners are going to come out and be nice and clean. So that was kind of critical to get that dimension right. If you know your saw has a good accurate gauge on it, none of these saws are all that exact. So I actually bought this bevel gauge tool to measure and make sure I'm getting 36 degrees there. Then I run all the pieces through. It's a rough cut at first because it's still a square edge here. You're getting your first 36 cut here. Then I go and do the other side, and this time I have to very carefully assess the width because my width target is going to be an exact, in this case 5 3/4, which they are exactly. That's 5 3/4 exactly, right? It's very, very, very close. A little bit big, but that's perfectly fine. I'd rather a little big than a little small because I have a concern about the driver getting on there, right? So after you've done your first cut, then you go through, and your second cut is going to establish your outside width, and of course that determines your inside width, so you have to keep that in mind. Then for gluing these together is another task. That I have used a very simple procedure in the past that was very simple, in which in which I took some straps. These are straps that I should bring it up. These are straps that you use to hold down any cargo you might put in the back of a pickup truck or a flatbed or something. And you got a little ratchet that will ratchet the strap and make it tighter and tighter. The issue is with the old boxes that I was making, like the one I showed you earlier, that was made out of MDF, and I didn't care so much. I just took a piece of cardboard, cornered it with cardboard, wrapped those straps around it, cranked it down so the glue didn't absorb into the strap material. But then you had all this glue mess on the outside of the box that, because it's MDF, you just wipe it down and sand it. But in this case, these are laminated, oak laminate on this plywood. And I didn't want the glue here. And so I had to come up with a different method. And what I did is I used 2x4s on these sides and put the 2x4s here, just laid them up, strapped the 2x4s down, and then the 2x4 pressed against the material, and this corner was left exposed. And that's when the glue all squeezes out, and I can come along with a damp rag and get the glue out and get the glue off of this panel. There's a little bit of spots of glue. Maybe you can't see that in the video, but there's little spots of glue here and there, but that will sand right off. That's not a problem. These are rough. I just finished this. But along here, you see a little bit of glue that got spattered. So you can sand that off, but if I just use a strap and strapped it tight with with the cardboard on there or something, that glue might be absorbed deeply into that. And then when you go to stain, that glue is going to resist the stain and you're going to see those spots. So that's a real challenge with this kind of material. It was easy with the MDF. You could just run the strap on it and sand it down until you can sand that MDF until you get the glue off it. This will absorb the glue, this wood, and that's going to be a challenge. So that's what I was doing using 2x4s. I'm going to use a combination with a larger box of sets of 2x4s with a 2x2 on there to get so that material is out this wide, and then your material is out this wide. The strap comes around that and doesn't touch this corner. These corners are now exposed, and I can come in with a damp rag once I clamp it down and the glue squeezes out, that I can come along and get that glue off the panel. The other issue is that you got to make sure, see this one, the truth be known, this one, as you can see that, it's not quite exactly flat. One of the ways around that, well, my table is not flat, I'm sorry. Yeah, see, that's really bad. And then it is, down on a flat surface, I can tell this is not exactly flat. I didn't do as good a job on this as the others because of the way I was strapping it. So that's a challenge. What you can do is, instead of using wood glue on the top, you can use this material I've been using. I used it on this. It's a power grab material. It's a bit thicker than wood glue, very, very strong. And it will take up a little bit of the gap that might be left in any of these panels, where there might be a little bit of a gap here. So you put that material on there, put your panel down, your top panel. One other issue then, just to use this as an example, once I put a top panel on there, you're going to see this edge, this plywood edge. And so what I'm going to do is take a piece of hardwood, cut a very, very thin strip of 3/4 hardwood, and then glue that strip on here. It'll stick out just a little bit. I thought about setting this in, putting the hardwood on there, and then cutting it. Oh my gosh, that would be hard. It's only just so much that I can do in a wood shop, in my shop downstairs. So I'm going to make it flush just like this. Obviously, it'll be a different piece of material, right? But I'm just using this as an example. But you'll have this plywood edge here, so you have a nice hardwood laminate top and laminate sides, but this edge you're going to have to cover. So I'll just get thin strips of 3/4. You buy the hardwood panels in 3/4 width. You just cut a thin strip of that material and just glue it on, and then glue another one here, glue another one there, and in the back, I think in this project, I'm just going to paint the back flat black and not have to bother with staining it or whatever thing, and having to put the hardwood materials on the back. It'll just be all painted flat black. So just the front will have the stain and the polyurethane. So those little hardwood strips will come along the edge here, both top and bottom. I need to add a quick addendum to my video. These are the larger boxes I was building parallel to the small ones. And the strapping procedure I talked about, I learned a few things about. You learn as you go along here. And I was using 2x4 studs to strap these down to get the strap off the corner here. So I wanted to mention, I did the second small one. I finished the first one, and I wasn't very happy with the way it works out. Trying to use those 2x4 studs underneath. Yes, it does get the strap off the corner, and you can get in there and get all that glue out. But getting these panels to all line up, one of the secrets is when you strap it right against the corner. And what that does is forces these pieces to level out so that they don't stick out one way or the other. It's much easier to get these 5 panels to all line up and create a nice uniform pentagon shape when the straps are right against the corner and against the material rather than out on studs. So I changed my mind on that, and I wrestled with how to do this. In the past, I had used cardboard against the corner, and that at least got the glue off the strap. But of course, it forced the glue into the panel. And with MDF, that's fine. You can sand it off, as I say. But in this case, it was important that I try to keep as much glue off of these laminated plywood pieces as possible, so that because otherwise, with a lot of glue absorption here, you will create a spot where the stain won't go in, and you'll be able to actually see those spots, and that would be a problem. So I took a piece of paper towel. All I did was to take pieces of paper towel, tape them on. You see the blue tape. This blue tape is used because it doesn't leave a mark when you pull it back up. It's painter's tape. You can buy that in any box store. And so you put the piece of paper towels, you tape them down to, and I'm actually measured exactly where they were going to be placed so they'd all line up. So I'm about 5.5 inches on center here. Doesn't matter what the measurement is, and I taped the first pieces of paper towel on this side of the panel, on this one, and then all the way around. Now you have, now when you take your panels, putting the glue on, by the way, I go along the edge, I put a bead of glue, and then I take an old paintbrush and I paint the glue in and really get the glue dispersed across the whole edge of that glue joint. And I do it on both sides of all 5 panels, so I got to do that 10 times. That gives me a nice glue surface on all the panels. But of course, there's a lot of glue around, and the glue starts going everywhere once you put these up. Now set the panels on your flat surface, your gluing surface, and you just set the panels together and they will kind of stick. Then the procedure I did with the first one of these that I didn't do here, you then take more pieces of tape and you wrap this a paper towel around the corner and then tape it down. And you tape all 10 of them down. Now the box will kind of just stay in place. It won't just fall apart, fall down. Now you take your straps and you put them on, and it's a little bit of work because you got to grab one onto the other. And you got to put the strap in place and get it around and get it so it's lined up with all the pieces of paper towel, and you hold it out and then you crank it down until it tightens up. Then you've got to check and make sure your panels are all nice and flush, that all the panels are nice and flat, and that the corners, even though we're strapping them like this, the corners sometimes will be moved one way or the other, and so you got to get those lined up. And this is Tight Bond 2 glue. It would take at least 30 minutes to really start to get to set. So you've got a few minutes to play with this. So even after I had it all strapped down, the panels weren't quite where they should be, and so then I was able to loosen these, and you can just move the panel around a little bit and get it just right. And then you crank these back down. I only cranked them two steps, so I'll show you this. So it works out pretty well because the idea again is to, and I already took this off once, but you see there's just a little bit of paper towel left on that glue joint and a little bit of glue there. So what glue did come out did get absorbed into that paper. Now that paper will just sand right off. So let me share briefly how I've cut the 5-sided shapes for the tops and bottoms of the boxes. I'll start, this is the 5-sided box, all with the sides all assembled. And I will identify one of these panels as a front panel, and I mark it. And the reason for that is these don't come out perfectly shaped in a 5-sided shape. Each of the angles is a little different. So you've got to custom cut the tops and bottoms. So what I'll do, since I want this surface that's going to be the very top of the top piece, I want to cut on this piece. And so I'm not going to take the top and put it like that. I'm going to take the bottom of the box and lay it down. And then that will transfer to the top of the box. I hope that makes sense. So because I've got to cut this top side instead of the bottom side, because the blade on the top side is not going to fray the laminate material. So starting with the grain going this way and the grain of the front piece standing up, that's done deliberately. So the grain stands up, it looks better that way. Now I'm going to have the grain run this way across the top, so the front is going to go here. And I will put that in, I will mark this out with a pencil. And now I'll take this on the saw. I might pre-cut this down so that it's a small piece, easy to manage on the saw. So here's my piece for that box, and this is the top surface. And so it's going to sit on top of the box that way. It's going to be marked on this side where the bottom of the box is put on there. This is already cut, but of course I want to just show you that with each of these angles, you've got to, if I'm going to do it on the table saw, the reason I want to do it on the table saw is I can get a nice, clean, straight, flat cut for each of the sides. The challenge though is that each of these angles again is not exactly 54 or 36 depending on how you measure it, but it's not exact. They're not all exactly the same. So each one of these has to again be custom cut, and then for each of these cuts now I've got to set the miter here at a particular angle. What I did is by eye I lined it up. It's not lined up right for this piece, but I had to line up the pencil line with the blade by eye. I have an idea for creating a jig that creates a board here that's exactly lined up parallel to the blade. Then I can take the piece and I can just line it up, get the miter exactly right, and then just run it through, and I could have the guide, the blade guard back on. But I took it off so I could show you this. So that's how I'm going to do each cut. I'm going to cut the first one, and then I'll take that cut edge, and I'll line up the next cut with the pencil line lined up with the blade, and I'll make that cut, and so on until all the sides are cut. And I'm going to cut them a little bit big, and then if I want to come back, and I'll put it on the box and see how it lines up, and if it needs a little more of a trim, I might take and trim a little bit more off. Get it very, very close. You don't want to get it exact. This is the bottom piece on the box, and this being the front. You might not be able to see it in the video, but there's a little bit of an edge that sticks out here. I deliberately did that because I want to be able to sand that down so it's nice and flush. If it's under, this one's a tad under right here. So I'm trying not to do that because I want to have a nice flush surface, and I can create that with a sander. If it's undercut, then you got then you got a lip here that I can't fix really, because the laminate is very thin. I can't sand that laminate down. So these are the three important surfaces: front, side, where I'm going to need to cut that down, sand this down, so that it's nice and flush. And then in a little while, I'll come back and do another video showing you the hardwood pieces that I'm going to put on the edges here. So let me talk briefly about how I made the edging for the boxes. These are of course all finished now, but let me just talk about how I made those edgings. So we're using hardwood to cover that because it's hardwood laminate, plywood. So we're going to use a piece of this oak hardwood. It's the same material, right? And rather than have a squared edges on either side, I want to round these off. So I put this in the vise and took a router and ran the router with a half round adapter on it and ran it on both sides. So you end up with a piece. This would be what it looked like with the edges on either side rounded off. If you can see that this way, those edges are rounded. So that would of course be the length of the hardwood piece. Now I take this piece of hardwood, put it on the saw with the fence here set so that you can cut a thin strip of this hardwood off. And so I ran it through, and you get these long lengths. This is just, of course, a short spare piece that's left over, but I had long lengths of this hardwood stripping. Now, it needed to be thick enough so that it would sustain being handled. If it were too thin, it might break easily or not glue on there and have a problem. I actually had to use nails to nail in. I used 3 nails in here and drilled holes and nailed this in place. So I put some glue in, and then I put the nails in, and that kept it firmly in place against the plywood until it dried, and then of course the glue takes over and does the work. And then of course I had to, once I had these pieces, I had to cut them to length, and I had to cut this angle edge here so that those matched up, and then I was all done with that. Then of course you've got to come in with wood filler and fill all the little cracks in and get it all nice and clean. Then you come along with stain, and then you come along with the polyurethane. Here's a close-up of the satellite box all finished. The issue that I had, that I saw, was that if you can see that in the video, the edging seems a little large on the satellite boxes as compared to the edging on the large base boxes, and that's because, of course, the edging is of the exact same size, and yet comparatively the edging seems quite fat on the satellite boxes. I guess they look okay. I thought when I first put the edging on, it looked kind of big, especially compared to the edging on the base boxes. So here are the two pairs of boxes all finished with the satellites sitting on top of the base drivers. That's the design intention here, that the base boxes double as a stand for the satellites. And this keeps the base driver somewhat off the floor and gets that tweeter up at about ear height. And so that's the idea. I didn't show you this, but this is I put a felt bottom onto the bottom of these boxes, so they sit on here, and it's nice and soft. And then there'll be spikes that go onto the bottom of the base boxes so that they're isolated from the floor, and that will stand them up just a little bit. So if you want to look at these in the whole project, that's another video. You'll have to go chase that down. It's going to be a video about building your own speaker systems, and I'll be talking about this project in that video. So you'll have to go there for that to see these all finished and playing. That's about all I have. Feel free to leave comments, and we'll see you next time.